Hello, here is a video note illustrating the Salish Sea operational forecast system model for tidal current predictions, which has been out for about a year, frankly, in the semi, or what they called quasi-operational mode, and today it was announced it's fully operational. This is a phenomenal model for providing tidal currents all the way from the Columbia River up to the top of Vancouver Island here. And we're going to just take a look at some example right in this area here. And so we would go then to weather data, and then and I'm using Expedition for this. Expedition downloads this data in NetCDF and converts it to GRIB. And then I go to Expedition, and then I'll just draw a box here, say like this. And then here it is, OFS Salish Sea model. And we'll take the current, and they have 3 days, and they do it every hour or two, something like that. It looks like that. In fact, I'm going to change it to every hour. Default is every hour. Okay, good. And then say download. And so there it's downloading the data. And that's it. This is the beautiful current data. And then we can zoom this in. And then where do we read the current? We could actually go here, weather data, and then turn on tooltip. Or maybe I have to go to weather and then tooltip. And then you can read the currents here at this time. And this time is... now this is UTC 1500 H0. Let me go back to the beginning. That is the first one. And then here is every hour. That's 1600. And then we're going to watch these currents get stronger and then reverse like that in the straits. But the beautiful thing is this is actually vector data, and you can use it in your modeling when you're doing a computer optimum routing. Use this current data. So it's quite beautiful, easy to get. Now, I'm going to pause for a minute. I want to compare this to something, but I got to double check the times. So I'm going to pause for just a minute. Where do I pause? Okay, I'm back. I have some data I want to compare this to, and I had it set up to local time, and so I had to adjust that. So these are this beautiful current data, and I must say that we've compared this data multiple times over the past year with the harmonic station data, and there's a few stations around here, there's a station about here, and so forth. And we've compared the model data with that, and it always agrees really well with the harmonic data. But this has got to be better than the harmonic data by far, which is easy to show, and we've actually shown that for down in San Francisco Bay. But the thing I wanted to show here is right in this area, Canada has a HF radar measuring station. Is actually located on Race Rocks right in here, and those measurements look like this, and I'll put a link to this in the file. And this is now I've backed this off to 1500 UTC, and then here is the data at 1500 UTC that's measured. This is measured data based on an instrument that's located right about here. It doesn't show up. Well, actually, overlays, station placement. There's where you don't see the Race Rocks Island, but there's a Race Rocks Island right here, and here's where the antenna is located. That's measuring this. It's a HF radar, which we discuss online. But then, so here then you can look at this, and if you, at 1500, you look at, these are measured data. This is like 1.7 knots here. Over here, 1.65. 1.69. So it's like 1.7, 1.8 knots along here. According to the measurements, HF radar measurements. Whereas we go from here in the model data is all a little bit higher, 2 knots, 2.2 and so forth. Now here's 1.8 in this area, and here's also 1.8 over here, but the model shows it a little bit stronger right in this area here, and so forth. And then what we could do is step through, but the directions all about right, and then you can step through this and look at like here's where it's beginning to turn around. What is this now? 1800, and we go up to these measurements here and go up to 15, 16, 1800, and see 1800, you're getting a little more structure in the flow, and it's getting ready to start turning around. That's 1.2 knots. Now this is starting to turn up here, 1.4 knots. What do we have over here? 1.3 knots. So something like that. And this model's got this turned up over here, 1.7, 1.8. Still, the model's a little bit stronger, and then where it really, but you do see exactly when it's going to turn around over this great huge basin, not just 1 or 2 stations. So if we go up to like 20, I think the oldest data we have here forward is 120. The latest data we have from here is 120, and so forth here at 120. And you see at 120, it's already, this is going slack, or what they call slack. It's the change of the flow. It's a minimum flow. It's not really slack water. It's not still water in any sense, but it's just a change of the flow from one direction to the other. And you see kind of like a chaotic flow here, and we can see that developing here in the model as well. Anyway, I just wanted to show that there is that data that we can compare to, but as far as navigation goes, this Salish Sea operational forecast model current predictions are really remarkable, and Expedition has a beautiful presentation of this, and the data is in the GRIB folder as a GRIB file. So if you have another program you'd like to export this to and look in a different program, then you can export this from Expedition and view it in that program. I'll stop there.